For this session, we have with us Mr. Jaspal Singh, who is Principal Engineer with Center for Development of Advanced Computing in Mohali. So as you know, CDAC, it's a Government of India enterprise. There are 10 CDAC centers in all over India. So Mr. Jaspal has rich experience in doing projects involving microcontrollers. So he will share with you the fundamentals of microcontroller, and he will also demonstrate you the use of microcontroller, how we can use it in automation. So before tea break, he will be deliberating on the fundamentals. After tea break, we will have demonstration session. So now I request Mr. Jaspal Singh.
Thank you, sir. Thank you. Okay, that is the camera. That is the camera. Okay. So mic is here. Okay. Okay. Good morning, everybody. Good morning. Just quickly. Okay. Okay. Sure. Okay. They're all mechanical. Basically mechanical. Okay. Right. Okay. So very quickly, I am going to talk about microcontrollers. Okay. So very quickly, you can tell me what have you read anything about microcontrollers? Are you basically aware of the things? What is your background? All are mechanical people here? Mechanical. And which year in mechanical? You're students or you're already working somewhere? You're already working somewhere? That's students. Okay. Students of which year? First year MTech. Okay. And other centers? They're faculty members. Okay. So we have a lot of variety of people. And the faculty members are all mechanical or some other branches also? Production. Primarily production. Okay. Are they listening?
Yes, sir.
Okay, right. So we'll start the presentation. You can put this for hosting. Okay, so we'll talk about microcontrollers, their concepts and applications. And before I take you into the microcontroller area, I would just very quickly like to tell you, as Sir has told, CDAC is a Government of India organization, and we are working in primarily in advanced computing, but a part of our expertise comes into electronics also. Embedded systems, you call it, electronics, or there are various names. Some people call it professional electronics, and then you can, depending on, right. And under Ministry of Communication and IT, we work on computers and electronics also. So some of them, just very quickly to tell you that what exactly, why I have been called and why, what is the difference. We have developed one what is called a supercomputer. Is India's supercomputer, India's highest performing computer, is been developed by CDAC, which works at 524 teraflops. There's a unit for measuring that. So it's one of the good computers in the world, although not the best one, but one of the good supercomputers. And we work on various areas, including electronics, right? And electronics, we work on various things. There are 10 different centers. At Mohali, we work on electronics, which we call as professional electronics and embedded system, right? So we have primarily one is this greenhouse climate controller that we have developed, which you can just see. It controls the. Similarly, we have M Health, mobile health. We have industrial controllers. We have small things. These are small, very small electronics, which we wear them very small. This stethoscope is something like mouse, where you do some other things. Right, and we have ubiquitous computing where you have wireless modes. This is CDEC own mode. CDEC ने अपने बनाए हुए हैं ये modes जो आप XB वगैरह के लेते हैं, वैसे ही हम खुद बनाए हुए हैं हमने, जो आप मार्केट से इंपोर्ट करते हैं, वो सिमिलर मोड्स हमारे पास अपने हैं, राइट? सो दिस वाज द बैकग्राउंड एंड वी कम टू नाउ microcontrollers. Before I talk about microcontrollers, the students here may be interested in like why we are talking about microcontrollers. What is the link between this microcontrollers and your mechanical engineering, right? Normally we understand mechanical engineering as some physical thing which moves, which rotates or gives some energy, power. So that kind of things you are generally concerned with. Whereas in microcontrollers, if there is a microcontroller, you will not be able to see कि वो क्या कर रहा है, उसका काम कर रहा है कि नहीं कर रहा है, वो बाहर से कुछ नहीं पता चलेगा. जब तक कि उसकी कोई आउटपुट को आप चेक नहीं करेंगे, तब तक कुछ नहीं पता चलेगा. So is English better or Hindi better? Both. Oh, Karnataka people, yeah. Okay, I'll prefer English only. Right. So in the microcontrollers, you cannot see whether it is operating or not operating unless you check the output or some voltage or some current or some parameter. So there is a big difference in these two, but the microcontrollers can enable your mechanical things, working of the mechanical things. So that's why we are learning about microcontrollers, and we all know most of the mechanical engineers are very much interested in automation, robotics, robot banana, and use it for various purposes. Most of the applications like security, like your transport management, the big mechanical things, your process industry, a lot of robots are there in all these places. And nowadays with electronics, mechanical things, and the computer, which we call as information technology or ICT or whatever names you give it to, but all these things combined, they have converged. They are being used for similar application. All of them are being used for combined combined way they are being used, right? So this is what we are, why we are interested in this. So very quickly, before I take you into because if I start delivering the microcontroller lecture, what are the ports and what are those things, you'll feel slightly bored, because unless you know the background and all the things, it becomes difficult to grasp them. So it is better to give less of your details of the microcontroller and more of the things around it, right? So I'm talking about this electrical and electronics. So again, you may not be able to appreciate what the microcontrollers are doing unless most of the mechanical people may look at motors as their main things for them. Motors are definitely important for mechanical engineers. Motors enable motion, which is an important part of the mechanical engineering, but there is small difference between electrical motors and various electrical things and electronics. Microcontroller is electronics and motors are electrical, right? Can anybody tell me what is the difference? Electrical और electronics में क्या फर्क है? What do you think electrical and electronics, what is the difference between them? Okay, anyway, I'll tell. Electrical, we are talking of energy, power. In electronics, we are talking of signal. Although again, energy and power is of concern, but electronics may the signal is more important. For example, your AC, for example, you're using the electricity for tube light, fan, various things. Okay. What voltage you are getting? 220, 230, 50 hertz. Right? So 50 hertz means 50 cycles per second. So we are not bothered about 50 hertz. Kitne wo hai. We are not bothered about those things. More of important in this tube light and fan is kitne watt ka ye bulb hai. What is the wattage of this bulb? What is the fan speed or how high speed fan hai, low speed hai, yeah, what type of fan, that way. So we are not the AC wave is of not concern. But if you're talking of electronics, then 50 hertz ki 51 hertz hai, that is more important. So in case of electronics, it is the signal, it is the information that is more important. In electrical, it is the energy, it is the power that is more important. This is the small difference. Then another important thing for you, for everybody, is analog and digital. Most of us normally live in an analog world. Most of us, we live in an analog world. Things are analog. Just like you have seen analog watches, digital watches. Analog watches, the circle rotation is linear. The circle rotation is not in steps, it is continuous. But in digital, it's in steps. If it is a 1 second step, it is 1 second. You cannot go lesser than that. If it is a 0.1 second to 0.1 second, whatever is the resolution or least count. But if it is a digital, it is between this and this step, there is no difference. But there is only one step, either here or here. Between them, there is nothing. So the machines which are digital, they understand two levels. Normally, when we say binary digital, they understand only two levels. There can be other types of digital also, but normally when we generally talk is binary digital. Binary means two levels. So either it is low or high. So there are only two levels we are talking in digital, commonly talking, low level or high level. Beech mein kya hai? Not defined. Right? But in analog, you can have 0 volts, you can have 1 volt, 2 volt, 3 volt, whatever. जो भी आपको बीच में भी है तो वो you can tell. Obviously depending on your instrument. Instrument तो है ही है. अगर instrument ही नहीं है तो उसके बीच में क्या देखोगे? But the point is, analog is a continuous thing. Digital is in steps. Right? The digitals and mostly there is analog electronics, which old radios you say AM, FM लगता था AM. Nowadays we have FM and we have many other things. But now earlier you used to have AM radio only, which was analog amplitude modulation, which is used to be primarily in the analog way. So it is a continuous thing. But in cases of digital, it can be in steps. So when we are talking of digital, we are talking of zeros and ones. Right? I'll just again speak on that also. Digital means you can have logical thing. Logical means if this is the logic, then this is yes or no. Yes and no. That is logical. Sequential means stepwise. First step, second step. So step mein chalta. And all these things combined, we have embedded systems. Right. So I hope you are understanding. You are in line with what I am speaking. Hello, all the centers, is that okay? Hello.
Yes, sir. We are from Gate Parampur. We are able to listen.
Right. So now embedded systems, we just now quickly, I showed you some background of electronics where we talked of digital electronics, analog electronics, and sequential things and binary logical things, right? So all these things, when we put together in some circuits, we call it as embedded system. Now, embedded system means a system which has embedded intelligence, which may have some sensors from the output to receive some output from the physical world, maybe some temperature, light, or something else, rotation, motion, linear motion, that kind of things. Those things are converted into analog, from those analog to into digital, and then processed, and then based on some decision, we do the some actuation, which means, for example, now let me link with your mechanical thing, right? Suppose you have a system, let us say you have this system, simple system fan. The fan is a simple motor, and you being a mechanical person, you want to analyze something of it, and you want to say if the speed exceeds this level, tell me this thing. If the speed is less than this, give some other signal. The machine should automatically speak something. Let us say you have this idea that if speed is more than this, let us say grow the green bulb. If speed is less than this, glow the red bulb. Let us say very simple thing. Now it is linked with your mechanical. Now how the electronics and automation or embedded system can fit into this and do this work for you, right? This work can be done by putting some kind of sensor which senses the speed. A sensor which senses the speed. There are various types of sensor which can sense the rotational motion. Tachometer is one. Uh, Recorders and things are there. Even more different things have come. You can simply have some kind of device like you have in recorders where the cutting of light is used to record. For even in cases of your car, you have some kind of wire which runs and gives you the output in a digital way. You have nowadays you have a digital meters, right? So similarly, you can have some kind of sensor which senses the speed, right? There are optical sensors also which give the light, right? Which give the light, and based on the light, they will sense the speed of the fan automatically, right? So suppose you have that sensor which measures the some speed, then that speed is to be converted into some value, right? Suppose you have said that if it is greater than 50 rpm, give me this green. Now that 50 rpm, somebody has to say 50. Abhi speed kitni hai? There may be some sensor. The sensor will give some output. The output will be converted into some value, which is 50, 51, 57 or 40, whatever. Okay? So that value is to be converted into some digital, right? So this digital value will be compared with what you have already programmed or you have asked. You may have asked कि 40 से ज़्यादा होगा तो green, or whatever, 50 से ज़्यादा होगा तो green. So the processor, the controller, which in this particular case I have shown as CPU. CPU stands for Central Processing Unit. So if that CPU will decide whether the value exceeds your value or not. You have given 40, it will compare with 40. If your input value sensor is giving some 45, it will say 45 aa raha hai. So therefore, it will give a green LED will glow. Right? So although it appears very simple, but it is a complex system can be mapped in this way. Right? So there can be sensors, some conversion, some processing unit, again analog conversion, and then actuator. Right? All this can put together will make an automated system. And the heart of this thing जो इसकी मेन चीज है, the main thing in this is CPU, and that is where the microcontrollers are coming in. ठीक है? So all these things, why I told all these things is because it is the microcontroller which finally will decide what to do, right? So microcontroller is something, is an electronic device, is a miniature semiconductor IC, is a circuit. ठीक है? अगर उसको exact definition हम बोलनी हो तो ये है, if we have to say the exact definition, it is a miniature semiconductor IC integrated circuit with built-in digital processors. This may be some memory and there may be some other peripherals also. Like you see this diagram. In this diagram, we have CPU, we have analog to digital conversion and digital to analog conversion on the other side, right? And obviously there may be software maybe here which requires some memory and some memory interface, right? In a computer, the CPU is a processor which may have a separate memory, separate conversion unit, separate serial port, separate this thing, all the circuitry may be different. But in case you want to shrink it to small, अगर आप उसने आपने छोटा बनाना है उसको, सारी सर्किटरी बड़ी है, तो छोटी करनी है तो सारी एक आईसी में डालेंगे, तो जब वो एक आईसी में डालते हैं तो we call it as microcontroller. The microcontroller is an example of a IC which converges lot of these things. ठीक है? उसके अंदर एक CPU भी है, there is a memory also, there is input output system also, there is input output ports we call, it is some mechanism to receive the inputs and give the outputs, and bus means a group of wires, group of connection, right? So you give some input, some things will happen and you'll get the output. This is what a microcontroller is. And based on microcontroller, based on this simple thing that you give some input, some things will happen in the microcontroller, you'll get some output. The idea is simple this, but based on this simple thing, you can do a lot of things. And these are the examples of what you can do with a microcontroller based thing, right? All these things are microcontroller based. You have some microcontroller in each of these things. Most common simple things is the mobile phone nowadays. There's a microcontroller or a processor is one and the same thing. I'll just talk about that also. A small difference is there, right? So all various systems, you whatever electronic item you think, there is either microcontroller or microprocessor in that system. Computers have it. Even nowadays, your washing machine, which is more of a mechanical thing, washing machine में बहुत सारा mechanical ही है, but still nowadays you get washing machine which is having electronic microcontroller in it. आपने देखे होंगे new washing machines have fuzzy Videocon निकालता fuzzy thing. Some other company will come out with some other version, some automated, some intelligent washing machine. So all those systems are based on actually microcontroller. So all these examples are systems, are examples of your mechatronic system where mechanical thing as well as some electronic things are integrated, right?
Embedded system and this microcontroller both are same.
Anybody who wants to say, answer anything to him?
Embedded system and microcontroller.
Embedded system and microcontroller में कुछ फर्क है?
Microcontroller is more part of embedded system. By combining microcontroller with some mechanical instruments to get the
Embedded system. Right. Any center wants to speak anything? There is a question here. What is the difference between a microcontroller and embedded system? Anybody like to say anything? Everybody is busy in their own thing now. Okay, fine, no problems. Uh, Answer has also come. Uh, Embedded system is a system. It consists of many things, whereas microcontroller is one small part. Microcontroller is a part which is very important. सबसे ज़्यादा main तो वही है, but is a part. Again, it's a part. So embedded system is a system which has the microcontroller, which has some sensors, which may have some more things, may have some mechanical thing also. Embedded system is a system which has embedded microcontroller. इसलिए उसको embedded system बोलते हैं because उसमें embedded है intelligence, and microcontroller is the symbol of intelligence. The symbol मतलब it holds the intelligence. It is something that enables the intelligence, जिसकी वजह से वो intelligence काम करती है, right? And just to take you more into your interest area, because all the centers I've seen, remote centers are having some other time pass. Uh, the car is one of the most mechanical. People love it. You know? The car is a purely automobile thing and a purely mechanical thing. But nowadays, cars have got microcontrollers. Most of the modern cars are having microcontrollers. Can you just tell me what are the microcontrollers used in this for?
Most of the cars nowadays.
Can anybody else also speak?
Acceleration is also done. Viper system.
Viper system.
Seat belt is open.
Pardon?
Seat belt is open.
Okay. Anybody else? Any remote center would like to say? What are the microcontrollers used for in a car? ऐसे नहीं बोलेंगे ये यहाँ पे लिखा हुआ है. What is this? Banood एक. Hello, Gyan Jyoti. Hello.
Hello. Hello, sir. Can you hear me?
Yeah.
Sir,
Yeah.
we have the systems of embedded, like all the automation parts, like we have the back cameras, then we have the automation systems, we have the sensors for temperatures, AC coolants. These are all comes under the embedded system parts, which are used in the car, automobiles.
Yeah, good. There is some small difference I would like to point out, but let me hear other centers also. Yes, Enathur क्या कहते हैं इसको? What is the name? Yes, Tamil Nadu center. How do you think a microcontroller is used in a car? Is it useful for car? Any thoughts? Okay, thank you. No problems. Gate Odisha. Hello.
Yes, sir.
How do you think microcontrollers can be used in a car?
To see how the performance of a car in a dashboard, the microcontroller can operate the signals for the measuring the various temperature or power consumption or fuel consumption.
Right. That's good. Yeah, that's a better answer. Yes, that's a better answer. Hoshiarpur. Hello. Sir, I'm just trying to make you interested in this. How do you think a microcontroller can be used in a car? कार में क्या करता है माइक्रोकंट्रोलर? Sorry, we are not able to hear you. No problems. Okay. You see, Gyanjyoti has given good answer, and Odisha has also given a good answer. The students here have also given a good answer. But small things I would like to point out. One, there is a wiper controller. There is an indicator for your speed. There is a let us say cameras for the front or the back or whatever, sensors, distance sensors. So all those things are electronics which may or may not have a microcontroller. For example, your wiper can have a simple sensor. If there is a rain, automatically start the wiper. There may or may not be a microcontroller because the intelligence may not be so much of intelligence may not be required. It may be simple one step. More than this, start wiper. No rain, stop. Right? It can be just this thing which can be done without microcontroller also. But there are certain things like control of your ignition, which is nowadays done with the help of microcontroller. There is a engine control system ECS, which is nowadays used in modern cars. ना अगर आप आजकल की कार देखें और पुरानी कार्स देखें, जब तक आपका इंजन स्टार्ट नहीं होगा, रन नहीं करेगा, तब तक आपकी जो है वेरियस सिस्टम्स काम नहीं करते. फॉर एग्जांपल योर ब्रेक विल नॉट वर्क, योर फ्यूल इंजेक्शन जो है वो डज नॉट स्टार्ट टिल दैट टाइम. Whereas in older cars, there was a different system. As soon as mechanically it is free, it will start. Here, the engine control unit is there, which controls not only the triggering of firing of that valve, but all the ignition, but it controls the valve also. You very latest system, you have a variable valve technology, variable VVT. What is that? Variable transmission. That is based on transmission. Okay, sorry. There is another system which I heard was that I do not remember the exact name for that. Is that you can vary the various parameters of the engine automatically by sensing. You don't need to do your mechanical things. Do not do it. Earlier you used to have a mechanical thing, wo ek spark plug hai, ignition hai, those kind of things would do it. Nowadays those things are done by electronic unit. So more than that, more than your simple wiper control or a camera or that kind of things, there are things which are being controlled by electronics, by a microcontroller inside them, right? So agar aap modern car ki service dekhein, the people most of the old people will not be able to do the service of a modern car because they say simply ki ye to sir it is some company based thing. The company people can only do it, I cannot do it, because there is some electronics control in it which people cannot handle, right? Which is not controlled, which is not seen. You cannot see ki aise ho raha ki nahi ho raha. It is only the electronics which will be able to tell you, right? So that is what I wanted to point out to you. It is where it is entering into your mechanical area. I can talk about the microcontroller for I take one full week class for microcontroller, but if I start speaking about microcontroller for full day, there is no use. So unless I make it more interesting to you by linking it with your things, right? So that is why I gave you all these things. Now I just let me come to the exact topic, exact hardcore items that you may enjoy or you may not enjoy. So there is a small difference between microprocessor and a microcontroller. Microprocessor is a small miniature IC which it does the processing, right? Information processing. It may not have some memory, it may not have any memory, it may not have various ports, input output ports, right? So a CPU receives the data from various other things and gives you some output, right? So for most computers we use a processor like your Intel. Jaise hamare what are the modern processors being used in computer? Intel i7, Core 2, this thing, that thing. So those are the processors which are meant for processing. What processing? What processing the information. So you give hundreds of millions of data to this processor, it will process you. It will process the data, right? But it is not good at giving the outputs in terms of physical things, in terms of input output ports. मतलब it is more useful for processing. Image processing करनी है, you can do very good in a processor, right? Whereas a microcontroller is again a IC, but it has a memory, a CPU, a timer, all the things built into it. उसके अंदर ही ये सारा कुछ घुसा दिया, right? So what it does, देखिए अगर आपने बहुत ज़्यादा मेमोरी चाहिए इसमें, what is the size of the memory in a computer? 500 GB hard disk, 4 GB RAM, right? So it is in the terms of GBs. GB means gigabytes, right? Giga means 10 to the power 6, right? So if you have to use big memories, big processor, big things, then the computer is the thing. सारी चीजों को अलग अलग कर दिया. Memory के लिए special चीज अलग, it goes separate. Timer अलग, ये अलग, वो अलग, right? So that is the way. But अगर आपने छोटी सी चीज करनी है, तो you want to make it small. So what you do, छोटा सा memory ले लो, छोटा timer, छोटा ये, छोटा वो, all the small things you put into one thing, and that's what we call as microcontroller, right? This is the small difference between the things, right? So it is a single chip which has all these things inbuilt into it. ठीक है? ये small difference, if you can remember, if you can make use of this thing in your mechatronics, I think 80% of the purpose of this is solved. कि microcontroller कब और क्यों use करना है? You learn, सारी पोथी पढ़ लो microcontroller की. If you don't know कब और क्यों use करना है, what is the fun of that, right? So you must understand these small things. That is why I am giving more time on these things. आपको बार-बार ये चीजें बोल रहा हूँ. Right? So microprocessor, microcontroller, कब आपने computer use करना है, कब आपने embedded system use करना है, microcontroller वाला, right? That you must be able to understand. Again, the same thing, but let us skip this. So coming back to this microcontrollers, as I told earlier, it has a bus. Bus is a simple interconnections, nothing. A CPU, which is a which primarily consists of what we call as arithmetic and logic unit, and a memory and input output, right? The input outputs can be serial or digital. Serial means output coming one by one, एक एक करके. Parallel means all the outputs are coming in same time. Memory can be of two types, ROM or RAM. RAM is random access memory and ROM is read-only memory, right? So which is used to store the program or the data. RAM is used to store the temporary information, right? For example, आपको बोलते हैं ना कि ये multiply 5721 by 9.5, तो आप उसको temporarily कहीं पे लिखोगे, इसमें इतना carry हो गया, इसका multiply, so that temporary things are done in RAM, right? So these are the components of a microcontroller, slightly more detailed than the previous one. Memory we said. Then the CPU, we have an important thing called ALU. ALU stands for Arithmetic and Logic Unit. You already know, you studied the subject, one course. Okay. Anyway, ALU stands for Arithmetic and Logic Unit. So it is a circuit inside the microcontroller. It is a circuit which is designed to enable arithmetic processes, primarily addition. Arithmetic में primary सबसे main सबसे simple चीज है addition and comparison. बस उनके design, the circuit is designed in such a way कि 1 plus 1 आएगा तो वो 1 0 show करेगा. 1 1 is 1 0. But digital में I am talking 1 plus 1 is equal to 2. So in digital 1 plus 1 is equal to 1 0. Okay, so that circuit is designed in that way. Then you have bus. Bus stands for group of wires, which can generally be 8. 8 हम इसलिए कहते हैं, हमने डिजिटल जो सिस्टम्स जो भी बनाए हैं, by convention, by common idea, we have given 8-bit digital, right? Now, what does 8-bit digital means? Anybody? 8 bits mean any signal is converted into digital value which has 8 digits. That is called as 8 bits. बोर्ड पे तो नहीं कर सकते. Let us say there is a some signal. This with your analog, this thing. Let us say this is 0, this is 1, this is 2, 3, 4, 5, 6, 7, and 8. Some values are just randomly given. Now this is an analog system. In an analog way, between this and this, you can easily say 0.5 hoga, 0.6 hoga, something. Right? But when we are talking about digital, we either say this value or this value. Right? The simplest way you can describe this in a binary way is by giving this is 0, this is 1, either 0 or 1. ठीक है? अब आपको बोलते हैं ये भी दिखाना है, 0 भी दिखाना है, 1 भी दिखाना है, 2 भी दिखाना है. तो 0 1 से नहीं दिखेगा, 1 0 is 2, 3 वैल्यू से 1 1 पे 3 आ गया. इसको दिखाने के लिए मतलब 3 अगर मेरे पास So what I mean to say is that, look here, if I have only 2 bits, मेरे पास 2 ही चीजें हैं बताने के लिए कि सिग्नल कितना है, तो मैं क्या बता सकता हूँ? I can tell either 0, I can tell 1, I can tell 2, I can tell 3. But अगर 4 मैंने दिखाना है in 2 bits, I'm not able to show. मेरे को I'll not be able to show. 4 के लिए कुछ और मेरे को दिखाना पड़ेगा. मतलब मेरा इलेक्ट्रॉनिक सर्किट जो है, अगर if it is having only 2 things, 2 displays, and being a digital, you can either give 0 or 1. इसके अलावा कुछ नहीं दे सकते. You cannot give anything else. So 0 0 0 1 1 0 1 1 are the 4 symbols I can give using 2. Right? So like that, 8 bit means 8 symbols. 0 0 0 0 0 8 बार 0 लिखने से this stands for 0 and 1 1 1 1 1 1 1 1 is the highest number I can show in 8 bit. Right? This is what it means. So 256 is the highest number. Right? So if could you get the idea? 8 bit means we have assumed the word, the physical word, to be consisting of only 256 steps, right? अगर हमारे पास जो भी एनालॉग वर्ड को हमने मैप करना है, whatever we want to map from the analog word to the digital word, and if we assume only 256 levels, 256 चीजें ही हो सकती हैं, उससे ज़्यादा नहीं हो सकती, then that means I can do with 8 bits, right? So like that, अगर जितना if you want more precise things, you want more number of wires, more number of bits, right? So that is what it means by 8-bit. Most of the digital word microcontrollers, simplest, are 8-bit. The lowest value generally we talk of 8-bit. So अगर आपको if I say now you have to tell me the speed of the fan in an 8-bit system, how many different speeds can you tell? 256. So you can give 256 different values of the speed in an 8-bit microcontroller. अगर आपको 256 से भी ज़्यादा values चाहिए, so then you will have to go for more, right? Or you have to do some trick by 8-bit को भी उससे higher में भी कर सकते हैं, but वो उसे tricks लगानी पड़ती हैं, which is a complex thing. पहले ये दिखा दो, फिर वो दिखा दो, फिर unnecessary problems, right? So this is what we mean by 8-bit. Then input-output ports mean receiving input data from some sensor, output to some relay, some motor, something, that kind of thing. Then serial communication means serially one by one you have to do some communication. Timer unit, watchdog timer is something which keeps on working continuously. Analog to digital converter is also there in the microcontroller. Right? Most of the microcontrollers nowadays have ADC inbuilt. उससे ज़्यादा भी हो गया आजकल, right? Now let us come to this diagram, which gives you a very good indication of how a microcontroller works, right? Let me just explain this. You'll love it. This is given in a way mechanical people would like to be enjoy. You'll enjoy. So Odisha and Tamil Nadu, are you in line? Yeah. Yeah. Okay. 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 So just look at this slide working on microcontroller. This slide has shows the different components of the microcontroller in a way which is very easy to understand for us, right? It shows some watchdog timer here, oscillator and oscillator divider, some timers here, some special function registers here, SFR we call them. RAM memory stands for random access memory. Analog to digital converter, which receives the analog inputs from here and gives the digital output to this unit, control unit, which is control and logic unit. Then you have a accumulator, which keeps on accumulating something. I'll just talk about that. Arithmetic and logic unit, decoder, instruction decoder primarily, some program memory, program counter, EPROM, plus some power supply, right? So now when you give power supply, external power supply to the microcontroller, the things start moving. And you need to connect what is this called as crystal oscillator. This is the external component which is required to start the working of a microcontroller. So there are two things that are required for the working of a microcontroller to start. External two things required. One is this crystal oscillator and the second is the power supply. So as soon as you give the power supply and the crystal, there starts happening some oscillator starts working, right? Oscillator is nothing but it oscillates between tick, 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 something like you can say timer start हो गया, घड़ी चलने लग गई, the work has started, right? So when the oscillator starts, oscillator divided by n, there is some internal number which machine will automatically do. You can simply say let it be 1, no problem. So when the oscillator starts, let us say there is some beat of the drum. To show as example, every oscillation, every beat, there will be beat, tuck, tuck, tuck. Something will start happening in the microcontroller. To show you in an analog mechanical example, let us say there is a beat. At every one oscillation, there is a beat, tuck, tuck, tuck. Things start moving, right? And at every beat, the things move. First thing that moves is the program counter will start at this location. Whatever location, zero location is defined, it will start at that location, right? Let us say this is the location or whatever. So one plunger will come in at the one beat. the plunger will plunge in, and what will happen, whatever is there in the memory, this particular thing, rod, camshaft, or whatever you want to call it, what is it, camshaft, plunger, oh, I call it plunger, I don't know what is the exact name. So this thing will come and it will push whatever is the instruction here into this instruction decoder. Okay? At a beat, this plunger here will plunge in and push something from the memory into the instruction decoder. The instruction decoder will receive something. Uske andar kuch aa gaya. There is something that comes in, right? And when it comes in, it decodes it. Whatever is the instruction here in this memory, it will be decoded. The decoder will tell the, for example, let us say it has some work to do from memory, receive something from this. So it will receive something from this, right? Suppose the next beat comes, right? So right now what has happened? Memory se ek cheez utha li hai. Based on the instruction, based on the program memory, one thing has been picked up by the logic unit, right? Control and logic unit has picked up some information. Let us say it is a 0, 1, right? Then the next beat comes. एक बीट में एक ही चीज है, कंट्रोलर के अंदर 0, 1 आ गया. नेक्स्ट बीट में this thing will move. There. The cursor at the next beat, this thing will move down by 1 count, and the plunger will come here. So what will happen? The plunger will push the next thing. पहले इस वाली मेमोरी को भेजा था, now it will push the next thing because the plunger has moved in. This has gone up, right? So next byte will go into this. Okay. So next thing decoding is, let us say, increment. So पहले memory में आया 0, 1. Now the next thing is written in the memory is the increment. Increase it. So what will this do? Instruction decoder will come to know that I have to increase it. So it will ask the ALU कि accumulator में send the increased thing into accumulator. So the accumulator will receive, earlier it was having 1, now it will receive 2, right? So again a beat will happen. Again on the next beat, the next program will come. The next program, suppose it says, whatever is there in the memory, give it to the out, right? So the output port will receive the 2. So 1 आया था, उसको increase करके 2 दे दिया. Suppose it is very simple thing. So all the things work in this way. At every beat, all the things work. All the things work. At the one beat, this thing has come in. Decoder will decode the information. इसको बोला था ये memory इधर भेज दे. It has sent the data here. Timer will, suppose you have asked the timer to keep on recording the time, so it will keep on recording the time. Suppose you have asked the watchdog timer to tell me कि भी watchdog, it's a watchdog. Suppose you have asked it कि मेरे को 1 घंटा के बाद मेरे को जगा देना. So after 1 hour, for 1 hour it will keep on ticking. After that 1 hour, it will give you the signal कि get up, right? So all the things will work depending on your program, whatever you program. So whatever you program, that will happen in steps. At every beat, one step will happen. One next step, karte karte, it will work your all the things, right? And the good thing is that this beats happen in the terms of megahertz. Har second mein thousands of times this thing is happening. So therefore, although it is happening in one beat, you want to add 1 plus 1, it will take 3 beats. 1, पहले 1 आएगा, it will increase, फिर 1 आएगा, फिर उसको increase करेगा, फिर अगले step में वो नीचे देगा output में. But 3 or 4 beats it will take. But because these things are happening in so fast, thousands of beats per second. So for you it will be diya out aa gaya, right? So similarly for calculator, it may take hundreds of cycles for one big calculation that you may give, but for you it is just a not even a second, because the calculator is working in megahertz, thousands or maybe lakhs of times beats per second, right? When I am talking of megahertz, that means lakhs of beats per second. So lakh of operation are doing in 1 second. So therefore it is very fast, right? Although everything is happening in steps. So it is these steps you have to understand. For doing anything into your mechatronic thing, you have to understand the steps. This step, then this step, then this step. If you understand the steps, then you can implement the program, right? That is the idea. What is the time? Are we? 11:15 we are supposed to break, na? Or 11:30? Okay. Okay. So this is how the microcontroller works, and all these things happen in electronics way. There is no plunger, there is nothing. It is only that at every beat, the next instruction will be passed on to the decoder. And beat is just to show you as a mechanical example, but it is a tick of the oscillator, which can only be seen on an oscilloscope, and otherwise you cannot just see it, you cannot hear it, you cannot happen. It just is not there, right? It happens millions of times per second, right? So how? So this is the program I said you can give some kind of program in this program memory, and it will do that in steps, right? So how do we do this? This is done by first writing a program. Steps में आप उस program को लिखते हैं, then you give it to the PC. मतलब PC के ऊपर ही लिखेंगे obviously, और तो कहाँ लिखेंगे program? You write the program on the PC, and there is a small circuit which is called programmer. This circuit will pass it on to the microcontroller, because the language of this, जो आपको language समझ आती है और जो microcontroller को language समझ आती है, it's a different. So we need all these things in between, and normally this is shown as a programmer, this is a microcontroller. ठीक है, ये microcontroller है छोटा सा IC, ये programmer है, ये PC को connected है इधर, ठीक है? कंप्यूटर से आ रही है ये वायर, ये प्रोग्रामर है, और ये वायर इसको कंट्रोलर को हमने दी हुई है, राइट? सो यू फीड द प्रोग्राम फ्रॉम द कंप्यूटर इनटू दिस, एंड देन दिस थिंग, दिस आईसी विल बी फिक्स्ड इन सम सर्किट. सर्किट में लगने के बाद इट विल कीप ऑन डूइंग द थिंग्स वन बाय वन, स्टेप बाय स्टेप वो चलता रहेगा, राइट? सो दीज आर द टाइप्स ऑफ माइक्रोकंट्रोलर्स, और टाइप्स नहीं, आई शुड से एक फिजिकल फॉर्म ऑफ द microcontroller. It can be a simple your DIP dual inline package, जो normally हमने IC देखे होते हैं, but आजकल DIP का काम बहुत कम हो गया, कोई नहीं इसको पूछता. This is SOIC, छोटे हो गए. ये इतना बड़ा controller has now come into small size of these types, or even these types. Here the pins are on two sides, here the pins are on all four sides. This we call SOIC, small outline package, and this we call as quad, QFN, or various other names are also there. Quad package है ये, चारों साइड में इसके टांगे हैं, right? So coming to the controller types, you can एक बहुत ही simple तरीका है. There is a simple way of telling the types, is that 8-bit, 16-bit, 32-bit. Right? Nowadays your processors are coming कितने bit के हैं? 64. Processors are 64 bit, but microcontroller अभी 32 bit में ही most of the काम चल जाता है. Microcontroller 32 bit is supposed to be a very good microcontroller. नॉर्मली 8 बिट यूज होते हैं, थोड़ा सा अच्छा काम करना है 16 बिट, बहुत ही कोई फंडू काम करना है तो 32 बिट, राइट। सो एक एग्जांपल मैंने यहाँ पे दिया है, पिक इज अ सीरीज ऑफ माइक्रो कंट्रोलर्स, जिसमें कि हमें ये सीरीज शो की हुई है, 8 बिट की सीरीज है, 16 बिट की सीरीज है, 32 बिट की सीरीज है, राइट। एक बीच में उन्होंने डीएसपिक फैमिली एक अलग से स्पेशल लगाया हुआ है, विच इज अ डिजिटल सिग्नल प्रोसेसिंग, वो थोड़ा सा अलग काम के लिए लगा रखा है, बट ठीक है। फॉर यू टू अंडरस्टैंड इज दैट तीन टाइप के मोस्ट प्राइमरी वे ऑफ टेलिंग माइक्रो कंट्रोलर टाइप्स इज 8 बिट, 16 बिट, 32 बिट, राइट। देन देयर आर अदर वेज आल्सो ऑफ टेलिंग कि भी उसके अंदर मेमोरी कैसी लगी हुई है। देयर में बी माइक्रो कंट्रोलर्स विदाउट द मेमोरी और बिग मेमोरी। एक इंस्ट्रक्शन सेट के बेसिस पे हम माइक्रो कंट्रोलर के टाइप बताते हैं, रिस्क एंड सिस्क। रिस्क इज रिड्यूस्ड इंस्ट्रक्शन एंड दिस इज कॉम्पैक्ट इंस्ट्रक्शन। देन मेमोरी आर्किटेक्चर के बेसिस पे है, हार्वर्ड आर्किटेक्चर है, वॉन न्यूमैन है, प्रिंसटन है, और भी काफी सारे हैं। फैमिली के बेसिस पे है, जैसे मैंने अभी आपको पिक की फैमिली बताई, ऐसी एक 8051 एक फैमिली है जो काफी सारे मैन्युफैक्चरर्स बनाते हैं। इंटेल, एटमेल, एसटी माइक्रो, बहुत सारी कंपनीज जो हैं A8051 सीरीज पे बनाती हैं। सो इफ मोस्ट कॉमन माइक्रो कंट्रोलर जो आप देखेंगे इज द 8051, राइट। And applications, you know, there are endless applications. This is a simple small robo which is has a but it works on the floor पे चलता रहता है अपने आप से डिस्टेंस देख के। इट हैज अ माइक्रो कंट्रोलर। कार में बहुत सारे माइक्रो कंट्रोलर के प्रोसेस पॉसिबिलिटीज हैं, इंडस्ट्री में है, कंज्यूमर में आपने देख लिया, देन हेल्थ केयर में है, अप्लायंसेज, ऑटोमोबाइल इंडस्ट्री में अपने रोबोस, वेरियस टाइप्स ऑफ रोबोस यू ऑलरेडी मस्ट बी अवेयर, जो पिक एंड प्लेस इज सिंपलेस्ट एग्जांपल। बट उसमें अगर आपने इंटेलिजेंस देनी है तो माइक्रो कंट्रोलर्स विल कम इनटू द पिक्चर। जितनी इंटेलिजेंस ज्यादा चाहिए उतना आपको माइक्रो कंट्रोलर के बेस्ड काम ज्यादा लेना पड़ेगा, राइट। एंड before we break, I just quickly tell you what can be the criteria for choosing a microcontroller. It is simply, सबसे पहले आपको देखना पड़ेगा how fast you want to do some process. अगर speed is important, right? अगर आपकी स्पीड है कि मोटर की स्पीड इतनी हाई है एंड उसकी 2 साइकिल से पहले मैं डिसीजन ले लूं, तो देन यू ऑब्वियसली नीड अ हाई स्पीड कि 2 सेकंड में उसको रोकना है, 2 सेकंड में उसको ये करना है, सम एक्शन, then obviously you need a high speed. But normally for most of our जो हम स्टूडेंट लाइफ में करते हैं, speed is immaterial. स्पीड हमें कोई मतलब नहीं है स्पीड का, कोई भी स्पीड हो, मतलब वो हमारे लिए बहुत ही ज्यादा होती है। मिली सेकंड में काम हो गया, बहुत है, इससे ज्यादा क्या चाहिए। सेकंड इज स्टूडेंट लाइफ में मोस्ट इंपॉर्टेंट इज पैकेजिंग, बिकॉज स्टूडेंट में इज वेरी डिफिकल्ट टू प्रोग्राम सम हाई एंड थिंग्स। तो उसको आपको कैसे वाला पैकेज आपको यूज करना है, दैट इज डिप। सिंपल, जो सिंपलेस्ट वाला है ना वो डिप है, वी कॉल इज डिप, DIP। वही वाला पैकेज आप लेंगे तो आप उसको आसानी से यूज कर सकते हैं। बाकी कोई ले लेंगे तो आपको पता ही नहीं चलेगा कैसे उसको यूज करें, राइट। इसको प्रोग्रामिंग मुश्किल हो जाएगी, हाँ, या फिर प्रोग्रामर भी साथ में आपको अलग से लेना पड़ेगा। या आजकल नए नए पैकेजेस और भी आ गए हैं जो कि सारा कुछ इकट्ठा ही सप्लाई कर देते हैं, एंड दे आर चीप ऑल्सो। So packaging again may not be so. Power consumption is also, इंडस्ट्री में अगर आप यूज करते हैं तो पावर कंजम्पशन बहुत क्रिटिकल हो जाती है, बट वो भी यहाँ पे जरूरी नहीं है। अमाउंट ऑफ रैम, रोम, कितनी मेमोरी है, आपका प्रोग्राम कितना बड़ा है, कितने स्टेप्स करने हैं, आपने हजारों स्टेप्स करने हैं। मोस्ट ऑफ द नॉर्मल वर्क दैट वी डू विद माइक्रो कंट्रोलर 2-4 हजार स्टेप्स तो बन ही जाते हैं उसमें, राइट। सो विच मीन्स किलोबाइट का डाटा तो कोई बड़ी चीज नहीं है। 1000 steps means 1 kilobyte, right? So kilobyte का कोई चीज जो है ना, kilobyte is considered to be very small program. So RAM, ROM कितनी चाहिए आपको, that depends what type of work you want to do. Another thing is number of IOs, input outputs, which means फॉर एग्जाम्पल आपने टेम्परेचर भी सेंस करना है, ह्यूमिडिटी भी सेंस करना है, और ये भी करना है, लोग भी देखने हैं कितने लोग बैठे हैं, उसके बेसिस पे आपने एसी भी चलाना है, फैन भी चलाना है, ट्यूबलाइट भी चलानी है। सो आईओज आपको ज्यादा चाहिए, इनपुट आउटपुट ज्यादा चाहिए। आपने एक ही चीज देखनी है, टेम्परेचर कितना है, एसी ऑन करना है कि बंद करना है, बस। अगर आपने यही स्टेप करने हैं तो स्मॉल वन इनपुट वन आउटपुट माइक्रो कंट्रोलर इज गुड। बट व्हेन यू हैव टू डू मोर नंबर ऑफ थिंग्स, यू वांट मोर नंबर ऑफ आईओज, राइट? फिर उसमें सीरियल पैरेलल का भी एक इशू आता है, वो भी ठीक है। अपग्रेडेशन, कॉस्ट एंड अवेलेबिलिटी। सो फॉर अस, फॉर स्टूडेंट लाइफ, मोस्ट इंपॉर्टेंट थिंग द अवेलेबिलिटी ऑफ टूल्स। कौन सा टूल अवेलेबल है, कौन सा माइक्रो कंट्रोलर अवेलेबल है, कितने का, पैसे का, बस यही चीजें से खत्म हो जाती है कहानी। बट इन इंडस्ट्री दीज आर द लास्ट आइटम्स। उसने जो काम करना है उसके लिए वो करेगा कि नहीं, दैट इज मोस्ट इंपॉर्टेंट, राइट? सो वेरियस कंपनीज गिव 8051। अगर आप और डिटेल्स इसके सुनना चाहते हैं तो आई हैव 8051 फैमिली पे कंप्लीट मेरे पास, आई टीच लॉट ऑफ अदर थिंग्स आल्सो। 8051 के बेसिस पे बहुत डिटेल्स हैं, एंड कितने पोर्ट हैं, कितनी मेमोरी है, क्या उसका प्रोग्राम है, कैसे करना है, कैसे असेंबली करनी है कि दूसरे में करना है, ब्लॉक डायग्राम क्या है, डिटेल्ड ऑल द थिंग्स कैन बी shown, but I don't think you require all those things now. उनको आपको ठूस ठूस के देने का कोई पर्पस नहीं है, right? So I think with this I'll stop here and ask you if there are any queries from your side. Yes, Gyan Jyoti, any question you have?
Sir, no question. Gyanjyoti College.
Right, thank you. Yes, Tamil Nadu. Anything you would like to ask? Odisha.
No, thank you, sir.
Right, right. Thank you. Anything else? Hoshiarpur? Chalo, right. Thank you. We'll break for the tea and join back after 15 minutes. Right. Thank you. ठीक है मैम। हेलो, हाँ जी, हाँ जी डैडी, हाँ बोलो बोलो। हाँ कोई नहीं, पैरासीटामोल इत्थे पई है, ਇਹਦੇ ਚ ਥੱਲੇ ਪਈ ਹੈ। ਸੌਖਾ ਤਰੀਕਾ ਦੱਸਾਂ, ਇੱਕ ਬੈਗ ਹੈ ਨਾ ਜਿਹੜਾ ਨਮਨ ਦਾ ਬੈਗ ਬੈੱਡ ਤੇ में ही उसमें चलेंगे ना तभी हो पाएगा।
मॉडल बेस्ड कंट्रोल,
मॉडल बेस्ड कंट्रोल्स में बहुत नॉट इजी इन दिस केस। एक स्टैटिक कुछ पूरे मॉडल का एक स्टैटिक एक इंस्टेंट पे तो स्टैटिक किसी से लेना ही पड़ेगा ना, एक इनपुट। हाँ, उस इंस्टेंट पे जो भी है यहाँ से इसको करके जो उसने प्रोसेस करना है डिफरेंशियली है, जो भी करना है वो करके फिर उसको लेंगे, चलेगा इसी तरीके से। माइक्रोकंट्रोलर में इसी स्टेप पर इसी चलेगा। अब आपने ये डिसाइड करना है कि ये स्टेप्स उसके कितने इतना फास्ट है, ये लेनी है फीडबैक लेके अपना मॉडल में फिर से रेट करना है, तो कितना फास्ट है उतना फास्ट आपको माइक्रोकंट्रोलर। Bit is resolution, speed is ये speed.
प्रोसेसर के साथ।
हाँ, bits is resolution. 8 bit में आप 256 levels ही decide कर सकते हैं। 256 levels of this can give you the input. तब तो 8 bit चलेगा। अगर 256 नहीं, उससे ज़्यादा चाहिए, तो फिर higher number of 16 bit, higher bit उससे 16 bit.
स्पीड इज
ये कितनी जल्दी चाहिए।
प्रोसेसर।
हाँ, ये आपने एक स्टैटिक इक्वेशन प्रोसेस करी, कुछ डायनेमिक्स चेंज हुए, उसको लेके फिर से प्रोसेस करना है, ये स्पीड कितनी फास्ट है। तो ये हाँ, मतलब ये करना तो इसी तरीके से पड़ेगा। इसके फर्दर कितने स्टेप्स आपने लगाने हैं वो आपके मॉडल पे डिपेंड करेगा कि क्या क्या पैरामीटर आ रहे हैं, क्या क्या यहाँ पे लेनी है, कितनी रेजोल्यूशन लेनी है। मतलब ओवरऑल अंडरस्टैंडिंग तो इसी तरह से चलेगी। Should we start? चला के देख लें पहले कि चलता भी है कि Okay, welcome back. Are the centers online? Okay. So, welcome back, friends. We will talk about some practical things about microcontroller. As you have seen, microcontroller is primarily an electronic circuit which can be programmed to do your activity, to do your decision making, to operate certain things as per your requirement, right? So the IC, as I showed in the some photographs earlier, is a simple IC which can be programmed in a language which we call as machine language. And machine language we cannot understand, so the next higher level is the assembly language, and even assembly language is difficult for humans, so we do it in high level language, for example C, right? So we program in C, the computer will modify it, convert it into some assembly language or machine language and put it on the microcontroller, and based on it the microcontroller will do the operation, right? So this is the idea, and here we will try to use one microcontroller. As you can see, this particular thing, ma'am, put the camera here. This is the microcontroller here. Yeah. Wow. Yes, right. Now, here I have a circuit board which we call as, should I put in some other way? यहाँ पे करने से थोड़ा better आएगा क्या? हाँ, अब better आएगा. नहीं, ये वाली तो जलानी है, ये जलाना. उधर आएगा. Should I bring it there? Okay. ठीक है, ठीक है. Okay, so this is a board by what we call as a Texas Instrument का एक board है. Texas Instrument का एक microcontroller आता है बहुत common, which is called MSP 430. MSP 430 based ये starter kit है. Starter kit means it is a kit which is having microcontroller. It has some what are the two things most important for microcontroller? I said कि उसके बिना वो चलेगा नहीं. क्या दो चीजें बताई थी मैंने? पावर सप्लाई और क्या था एक? Power supply and oscillator. Without a crystal oscillator, without power supply, microcontroller will not work. So this board is a board. Hello, other side of the there's an echo. Okay. So this board has you can see there is a crystal oscillator there here, and this is the microcontroller, which is a DIP package, and there are some more ICs. One is for communication with serial port, USB port, and another is about some other functions which we will not be using in this. So it has a built-in oscillator, and power supply will give with this from the 5-volt supply of the PC. Right? So we will try to use this and starter kit by simple programs. We will show you some example, like you can think of some simple things like blink a red LED or green LED for blink a LED for 5 seconds, turn it off for 10 seconds, then turn on for blink for 5 seconds or whatever, something like that. Whatever we want to program, we can do, right? Or simply let us start with the simple blinking on off, 1 second on, 1 second off, 1 second on, 1 second off, right? So that we will try to do, right? So for this, what is required is the PCB, the power supply, the oscillator, the microcontroller. These are the main basic things, right? and other than this we need to program it. So how we program it? There are different softwares available for programming the different microcontrollers. हर microcontroller को program करने का software अलग हो सकता है. Normally, every company who makes a microcontroller will also make a programming software. ठीक है? So हर company का software अलग होगा. Some common things may also be there. Like 8051 की family एक common है. तो वो microcontroller की series है 8051 family की. तो जो different companies 8051 series बनाती हैं, possibly they can be programmed with the same software. Yeah, there are companies which give softwares useful for n number of microcontrollers, right? IAR का एक embedded workbench है, which is world's most popular software for programming microcontrollers, but it costs a lot. बहुत महंगा है. हम for student level पे we can even simple demo version से ही हमारा काम चल जाता है. So I will use a software called Energia, which is Texas Instrument का एक open source software है, जो कि क्योंकि ये IC हमारा Texas का है, तो वो Texas का हम Energia open source का software हम use करेंगे, which I have put here, right? So I have installed the Energia here on this computer, and Energia I will click. So one simple program will open up. Now this particular software and the hardware are tuned in such a way कि जो program हम यहाँ बनाएंगे that can be transferred to this. In many cases, program बना के पहले it is to be transferred to the microcontroller through another programmer. Right? इस particular case में there is a inbuilt programmer. Because ये starter kit specially उन्होंने इस purpose के लिए बनाई है. ठीक है? So let us first see whether the software will look at this. सबसे पहले क्या है, software को ये नजर आना चाहिए कि ये कोई एक चीज यहाँ पे connected है, right? So I'll just make it full screen. And tools में there is a serial port. Serial port में एक सिर्फ एक COM port 4 पे है कुछ. Tools, yeah, right. Launchpad MSP 430 G2 is the MSP 430 G2 है हमारे पास. So let us see MSP 430 G2 series का कौन सा है. ये है, right? It is automatically detecting itself. ठीक है. Right. So now this is the program which we can burn into this. So उसने detect कर लिया कि ये इसमें लगा हुआ है. So whatever program we put in this can be transferred to this. इसमें हर program में ये जो Energia software है, इसमें program is very simple. There are few basic things in this. I'll just show you that basic ideas also. Okay, just let me orally speak. एक few slides are there which tells you कि इसके अंदर what are the things in this. Whenever you program, this is like a C program. You have to declare certain things. You have to do some operation, right? So there are two basic components of this program which they call as some in this window which you can see, which they call as a sketch, right? Void setup, some brackets are there. This hash, this symbol backslash shows you that these are the comments. So this is not to be programmed. This is just for comment for us. It says put your setup code here. Right? Setup code is something like you declare port number 1 is for this, port number 2 is for this, something like that. Right? Then there is a second part which says void loop. If you have programmed in C, you will know what does this mean. Void, this thing means this is a subprogram or some function is there, right? So void loop is something which will be looped continuously. Loop means it will keep on working continuously, right? So you declare certain things here and you put in the loop certain things. Like if we have to start the blinking of LED, we will declare here that so and so point is LED, okay? And here we will put a code that on for 1 second, off for 1 second, right? So that kind of thing is the basic idea. Now the easy way is to let us pick up some programs which I have already put in there, and the simplest is the blink, which is the program here, right? I'll just do it like this so that okay. Is the side part visible to everybody, na? Sometimes it gets blocked. Okay, so in this program you can simply see the first thing I've done is define LED. Some LED is some LED. We know LED is LED. So this particular software understands LED. Some basic words are there which you can separately look at, or I can give you the list. So red LED is again defined for this particular board. So it is, you define LED, red LED, right? So we are talking of red LED as a LED. So this what will happen? Initialize the digital pins and pin mode LED. So there are different modes. One is analog mode, one is digital mode, and pin mode is a individual pin wise, right? तीन तरह के mode हैं. One is pin mode. Pin mode means individual pin I am controlling, and if I am controlling the full port, then that can be controlled as analog or digital. ठीक है? So pin mode में LED is taken as output. So this syntax and all those things can vary from software to software. I do not want to take you into the details of exact these format, because the format and the way how it is written can vary from one software to other. And anytime when you are programming a given controller, you will have to look at that particular software method. जो भी उसका तरीका है, that you have to look into that only. There is no uniform international standard कि ये कर दिया तो सब जगह ऐसा ही चलेगा, right? So in this case, what we have done is we have given in the setup that pin mode LED, जो LED यहाँ पे define किया है, is a output type, right? I can have a pin mode, some sensor as a input. Input अगर sensor लेना है मैंने तो वो input लेना पड़ेगा. Output है तो that means the controller is just giving some output. It is not receiving any input, right? Then void loop में what we are looping, we are writing LED को high. High means 1 or high means full voltage, so it will glow. Then for 1000 millisecond it will delay, and then it will write what? Low. So after 1 second it will be low, then again 1000 second के बाद it will come back to this, because it is a loop, it is a continuous looping. So again it will glow, then after 1 second it will turn off, 1 second on, 1 second off. So let us see this simple program whether how it works, right? So then there is a function given upload, right? So this loads the program into your microcontroller. You can see the green bar there, it is showing, and if it loads, well, if everything's drivers are okay, then it will go. It will say updated, loaded. Right. Done uploading. So finally, I don't think you can see. It is here. It is written that done. कर दिया, upload कर दिया उसने. So what will happen? Now you can see 1 second के लिए on, 1 second के लिए off. It will happen. So you can show this also. So this LED you can see it is glowing on for 1 second, turning off for 1 second, right? Just to check whether this is the code that we have given. यही है कि ये पहले से ही चल रहा था. Let us modify this code by slightly. क्या करें? इसको on थोड़ी ज़्यादा देर रखते हैं, off कम देर रखते हैं. Let us put this thing as 10 seconds. 10 second बहुत ज़्यादा हो जाएगा, आपको wait करना मुश्किल लगेगा. Let us put this thing as 5 seconds on, 1 second off. Right? ज़्यादा देर on है, थोड़ी देर off है. Now let us see whether it will change. So it is now burning when the अभी तो वही चल रहा है, 1 second on, 1 second off, right? So you can see now it has started taking the new update. Now it is done. 5 seconds on, 1 second off, 1 second off, 5 second on, right? 5 seconds के लिए on, 1 second के लिए off, right? So it has, whatever we programmed has been transferred to this. Now using the same simple thing, we can give more examples. We have to up to 1 o'clock, na? Ki 12:45 up to 1 o'clock. Okay, so accordingly, let us see what programs you want. We can program those things and see. ठीक है? क्या देखना चाहेंगे आप? इसमें सेंसर्स तो नहीं है, स्विचेस हैं कि ये स्विच प्रेस होने पे ये हो जाए. That is one thing we can do. Other than that, there is a LED which you can program. इतनी देर के लिए on हो, इतनी देर के लिए off हो, वो तो आप हम देख ही रहे हैं. Anything else you want, you would like to see? और other than that, I can talk about MSP 430 की features क्या हैं, जिसके basis पे ये why we are using this, what is there. Analog read नहीं होगा, blink नहीं होगा, digital read fade. Let us do fade. Okay, this is a good. Okay, next we are trying to do a simple program with this. What will happen? The brightness should decrease. ठीक है, अभी तो on off कर रहे हैं हम. We are giving it in a pin mode on high और low. दो ही values दे रहे हैं, high, low. High में जल रहा है, off में बंद हो रहा है. Now suppose we want to change the brightness. उसके लिए हमें क्या करना पड़ेगा? उसके लिए हमें brightness कुछ value देनी पड़ेगी उसको analog. On off तो दो ही values होगी ना, digital, this thing, that thing. If you have to vary it in different steps, वो हम although हम अंदर तो digitally करेंगे, although the microcontroller will do it in a digital way only, but for a analog word it is different steps, more than high and low. High low, not just two levels, high low का दो level नहीं है, उससे ज़्यादा है. So for us, for a microcontroller, it will write in a analog way. So जिसके लिए हम analog write का एक function use करेंगे. जो कि इसका एक एग्जांपल यहाँ पे I have. So what will we do? This example will show how to fade a LED. Right? Now, what first of all we have declared some variables. इसको दिख रहा होगा? Should we? Can we enlarge this? है ना? Very difficult. Okay. We have declared certain variables as integer. You can because we are varying between 0 to 255. 8 bits है हमारे पास total. 0 to 255 हमने करना है, and those values will be integers. So we have given them integers. अगर हमने कोई processing का करना होता, जैसे आपके वो functions हैं, तो we could declare them as a float or some other thing, and then you have to do the handle them accordingly. Okay, so we have declared two variables, brightness and fade amount. So 5 के steps में हम उसको करेंगे. Again, pin mode में LED ले रहे हैं, output ले रहे हैं, input नहीं है. Loop के अंदर हमने कुछ रखा है. What we have written is that analog write green LED brightness. कुछ values हम mechanically. Well, you are part of this class. आइए बैठी. Okay. So now what we are writing is analog write. Some integer we are writing brightness. Some value brightness we will write. Okay. So when we say analog write, it means the computer, the microcontroller, sorry, will give you some value. Although starting में the microcontroller has it in digital, but it will be converted to equivalent analog. Right? So when we say 255, it means highest level of analog because 8-bit का सारा system है. If we say 0, analog write of 0, that means the lowest level. Beach का level 128, that means the exactly half level, right? Like that. So it will convert that. अगर आपका 5 volt का system है, तो exactly half would mean how much? So when we say analog write of 128 या 125 आसपास लगा लो, तो how much value will it give? Voltage value? Although answer is 2.5, but the answer is not big thing. But you have to understand ये मतलब जब तक उसका वो फायदा नहीं होगा, जब तक ये अगर आप ये point नहीं समझेंगे कि क्या हम कर क्या रहे हैं. Hello, remote centers, are you in line?
We are online, sir.
Yeah, and by asking in line means you are understanding.
Yes, sir, we are understanding.
Okay. Gyan Jyoti. Are we trying to do something useful or unnecessary? NI की lab है इनकी, NI lab की.
फिर क्या करना है?
Pardon?
आप बोलो चलो वो तो आप से बोलो लो सर इससे बोलो.
Okay, I understand. It's okay, everybody. Slightly relaxed, okay, no problem. After lunch, after tea, obviously it happens. After lunch तो इससे भी ज़्यादा शायद बिल्कुल ही सो जाते होंगे. चाय पीने से ही इतना मुश्किल हो गया सिचुएशन. चलो, yes, Tamil Nadu, had your tea, coffee, I believe. So, sleeping. And होशियारपुर तो वैसे ही ग्रेट है. आधे लोग कल ही चले गए होंगे. चलो, great. Some
Hello.
people are still there. Yeah, some people are still there. That's good.
हेलो,
हाँ जी.
दिस इज फ्रॉम ज्ञान ज्योति कॉलेज.
हाँ जी, प्लीज.
एक छोटा सा क्वेश्चन आपसे पूछना था सर मैंने.
प्लीज.
लास्ट सेशन में सर आपने एक पीपीटी दिखाई थी जिसमें पिक माइक्रो कंट्रोलर हम लोगों ने यूज किया था.
पिक माइक्रो कंट्रोलर यूज नहीं, चलो उसका थोड़ा सा ओवरव्यू ही दिया था. हाँ जी.
So we were having 8-bit, 16-bit, 32-bit PIC microcontroller,
Right.
and in 8-bit microcontroller we were having PIC 10, PIC 12, PIC 16, PIC 8, 16, etc. 18.
Okay.
है ना. तो हमारे चार जो उसमें PIC कंट्रोलर थे, they all were 8-bit microcontrollers.
Right.
है ना सर. मैं ये सिर्फ ये पूछना चाहता हूँ कि वो सभी अगर 8-bit प्रोसेसर है तो उनमें आपस में डिफरेंस क्या होगा?
Oh, okay, good. देखिए, there is simplest way of identifying the microcontroller is number of bits, right? Second, there are many other things that we need to differentiate. One is memory. कितनी memory हमें onboard देनी है? किसी में RAM ज़्यादा है या कम है, right? Similarly, there is energy consumption का एक पैरामीटर है. Similarly, number of ports का एक पैरामीटर है. So all these 4 controllers, which although are 8-bit, may have different parameters. Some may have more memory, some may have more number of ports, some may have inbuilt ADC, analog to digital converter, some may have analog comparator. So based on some understanding, the company will make multiple controllers of maybe of the same family, same number of bit bus, same data bus. So एक ही data bus के आसपास काफी सारे कंट्रोलर बनाए जाते हैं. इसमें तो आपको 4 ही दिखाए हैं, एक्चुअल में 4 नहीं, कम से कम 20 8-bit माइक्रो कंट्रोलर्स होंगे पिक के, right? So each of these will be different, will have different memory, different power consumption parameters, different number of ports, different facilities for analog processing. So different things will be there, right? Is that okay?
Yes sir. Sir, there is one more question.
हाँ.
Sir, actually जैसे हम लोग 8051 कंट्रोलर हम लोग यूज करते हैं,
जी.
and we are having a standard crystal frequency that is 11.0592.
Okay.
We are using a crystal having more frequency than that or less frequency, then उस ऑपरेशन में क्या फर्क पड़ेगा या सेम ऑपरेशन करेगा?
Right. What do you think? पढ़ना चाहिए कि नहीं?
So normally इसकी जो crystal frequency it provides basically crystal frequency से होता क्या है, हमारी जो साइकिल्स की टाइमिंग होगी वो चेंज होंगी.
हाँ.
तो अगर crystal frequency हमारी कम होती है then it will take more time, and it is more then हमारा टाइम होगा कम लगना चाहिए.
Right.
तो इस मुझे कंफ्यूजन थी कि क्या ये कंट्रोलर अलग फ्रीक्वेंसीज पे.
Right answer. Connection to you. You yourself have given the right answer. It is perfectly right answer. The only difference, only additional things I would like to put up is that you have the microcontroller has a set highest frequency that it can operate on. ठीक है. हर माइक्रोकंट्रोलर की एक हाईएस्ट लिमिट होती है, उससे हायर फ्रीक्वेंसी पे वो काम नहीं करेगा. दैट इज पॉइंट नंबर 1. ठीक है.
हाँ जी सर.
दूसरी एक उसमें और खासियत समझने वाली चीज है, वो ये है कि हर फ्रीक्वेंसी के बेसिस पे बाकी सारे काम हो रहे हैं. जैसे आपने 11 वाला लगाया या आप उसका 5.6 वाला लगाते हैं या कोई और वैल्यू का लगाते हैं, अगर वो माइक्रो कंट्रोलर के बाकी सारे पैरामीटर्स के साथ मैच करता है, समटाइम्स सम इन वेरी रेयर केस देयर मे बी अ पॉसिबिलिटी दैट इट मे नॉट मैच, उसका इंटीग्रल उसका नंबर ऑफ साइकिल्स उसके नंबर ऑफ साइकिल्स के साथ मैच ना करे, मतलब बिकॉज इट इज ए फर्दर डिवीजन एक्चुअली, द माइक्रोकंट्रोलर एक्चुअली डिवाइड्स इट इनटू further sub-cycles. So on a rare case, it may happen that you may not, or your oscillator may not match with the frequency defined for the microcontroller. But in general, the answer that you have given is right, subject to the highest limit of the microcontroller. अगर external frequency आप उसको कम देंगे, तो certain operation को, same operation को वो ज़्यादा देर लगाएगा, right?
Thank you, sir.
Right. The problem comes when you are doing some kind of communication, serial communication. तो वो 9600 baud rate जो है ना defined है 9600 standard baud rate. तो जो कंप्यूटर का स्टैंडर्ड baud rate सीरियल बोर्ड पे है, अगर आप वो उसका मल्टीपल नहीं देंगे तो वहाँ पे वो कम्युनिकेशन में प्रॉब्लम आ सकती है. सिमिलरली देयर आर सर्टेन प्लेसेस जहाँ पे क्रिस्टल फ्रीक्वेंसी जो है बहुत क्रिटिकल हो जाती है, समझनी पड़ती है. चलिए ठीक है. एनीथिंग एल्स from any other center? चलिए, okay, then we come to this fade program where earlier we used to simply say high और low, दो ही वैल्यू हम दे रहे थे. अब यहाँ पे हम एनालॉग राइट फंक्शन के थ्रू हम ब्राइटनेस की वैल्यू, यहाँ पे जो भी वैल्यू आ रही होगी उसको ग्रीन एलईडी को दे रहे हैं. Because we have said it is in steps of 5, so पहले 5 आएगा, फिर 10, 15, 20 ऐसे steps of 5 में चलता रहेगा, right? So पहले जो भी यहाँ पे हमने brightness क्या define किया, 0. So first value it will give is 0. Then brightness plus fade amount, वो 5 add हो जाएगा, right? Then until it is 255, it will, if it is 255 पहुंच गया, लिमिट पे पहुंच गया, तो फिर से वो 0 करके उसको फिर से स्टार्ट कर देगा. ठीक है. सो वो यहाँ पे प्रोग्राम है, बट आप सिंपली इस स्टेप तक ये समझ सकते हैं कि फर्स्ट टाइम राइटिंग 5, 10, 15, 20, 25 लाइक दैट, इट विल गो इन स्टेप्स ऑफ 5. ग्रीन एलईडी पे कुछ वोल्टेज आएगी विच इज प्रोपोर्शनल टू द एनालॉग, द वैल्यू दैट इज देयर इन दिस. ठीक है. द वोल्टेज विल बी प्रोपोर्शनल टू द वैल्यू हियर. Right? So if I say 0 means 0 and 255 means 5 volts, because we are using 5 volt system. अगर ये इसकी जो आउटपुट है वो 5 volts की होती है, जो USB पे हमारी वोल्टेज आती है it is 5 volts. So we are using a 5 volt system. So how much will 255 mean? 5 volts. And exactly half उसका 125 or something like that, क्या 130 क्या होगा? 2.5. Right, so it is like that, proportionally, directly वहाँ पे proportional चलता रहेगा. So let us like burn this system, burn या upload. Some people call it as burn, some people call it as upload. So let us upload this program. So this has uploaded. Now we should see this LED as slight going dim in steps of 5 and suddenly coming up to the full level. ठीक है. अभी इसको हम थोड़ा सा it is happening in very fast, almost very fast way, so you are not able to probably see it 100. Now you can see it is there. It is dimmed. Full, dimming, 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 full. Right? Are we able to catch it? थोड़ा इसको steps इसके थोड़े delay कर देते हैं so that you can see it slowly. यहाँ पे we will write delay. Let us say how much delay should we give? 1 second will be too much. 0.1 second उसको कर देते हैं, right? And so slowly it should dim. And now we upload it. So we are talking of the same thing. It's slightly slowly it will happen. It is uploading. Okay, uploaded. आ गया वहाँ पे. So when that thing comes there, uploaded. So वो upload. अभी धीरे it should dim. Now you can see this LED we are talking. It is still very fast. Now it is full. Dim, right? Gone. Then glowing up, full up, fully bright. Now it is fully bright, probably fully bright. Almost, it's very difficult for us to judge the value unless you have some kind of voltmeter or something. Now it is dimming. Dim हो रही है. नहीं, अब तो full है. Is it would be visible to the remote centers? हाँ, वहाँ पे ज़्यादा अच्छा बल्कि नजर आता है. It is clearer there.
It is visible on the system only.
Yeah. Now it is dim, very dim, then going up, right? It is increasing in value, and it has increased, probably increased to the, then again going down. So that is what we are doing. So if similarly you can think of some other program, we will do it right now. Some small example you can think of. You can think of some more examples. Read will not be possible because we don't have any sensor. Sensor, if there is a sensor, we can read also, but right now we don't have any sensor. Then, okay, let us see this button. Right. This particular program is supposed to turn on a light when the button is pressed. Right. Let us say you have some mechanical function कि अगर किसी ने ये कर दिया तो ये हो जाए. Right. So there are two buttons given in this. We can try using one button and LED for the output, input as this. Right. So the program here is already done these things. करके रखी हुई हैं सारी चीजें. And but अगर आपने करनी है तो obviously you will need to program this, understand these steps and program. Right. अभी quickly करने के लिए ये यार already जो रेडीमेड चीजें हैं वो अपन देख रहे हैं. Okay, so first thing we are giving some constants. Push button is a constant, green LED is a constant. We can define it in other ways also. Then int button state 0 or 1 दो ही है ये, right? You can define it in digital also as digital variable. Then void यहाँ पे सेटअप कर रहे हैं हम पिन मोड में, LED पिन को ले रहे हैं और बटन पिन को भी पिन मोड में ले रहे हैं बिकॉज इट इज ए सिंगल बिट का है. अगर 8 बिट के पैरेलल लेनी है तो वो पोर्ट मोड में लेना पड़ेगा उसको. Then what we are looping is button state is digital read. Here we are taking the input. अगर उसको एक बार दबाएंगे 0 हो जाएगा, एक बार दबाएंगे 1 हो जाएगा. ठीक है, that we are reading. And if button state is equal to high, then digital write high. एक बार high है, ठीक है. Else अगर off है तो digital write low हो जाएगा. ठीक है. You can also program it in various other ways. यहाँ पे simple if else करके लगा दिया है. If high तो high, if low तो low. Right. So let us upload this program. Okay, done. So the program has been uploaded into this. Now the button state is something, so this particular LED is growing. Let us see, if I press the button it goes off, right? It goes off, I release it, then comes back. ये बटन जो है ना पुश बटन बेल डोर बेल वाला बटन है, ये ऑटोमेटिकली इट कम्स बैक टू द हाई लेवल, ठीक है. सो जब मैंने इसको प्रेस किया इट गॉन टू 0 लेवल, राइट. सो टिल द टाइम आई एम प्रेसिंग दिस थिंग इज ऑफ. आई रिलीज आफ्टर अ डिबाउंस, एक इसके अंदर डिबाउंस दिया हुआ है. डिबाउंस इज मतलब गलती से कई बार अगर हाथ से ऐसे वाइब्रेशन की वजह से हो जाता है तो वो उतनी देर में ना हो, सो वी डू अ डिबाउंस फंक्शन. सो इनबिल्ट डिबाउंस भी है इसमें. सो व्हेन आई रिलीज इट एलईडी कम्स ऑन, ठीक है. सिंपल, कोई बड़ी बात नहीं है. सो बेस्ड ऑन दिस यू थिंक ऑफ सम गुड एग्जांपल्स दैट वी विल डिस्कस कि इसको ऐसे किया जा सकता है. whether we will be able to do it right now or not is a different issue because हमारे पास सभी सेंसर नहीं है. This is just to demonstrate कि how a simple program can be transferred to a controller and that controller will start working like that. Now for the rest of the life this controller will keep on doing this. जब तक उसको पावर है, जब तक उसका क्रिस्टल है, ये यही करता रहेगा, ठीक है, जब तक कि आप प्रोग्राम नेक्स्ट उसका चेंज नहीं करते. This is the difference between many of the programmable things like computer and this. Computer भी जब तक उसको कमांड नहीं दोगे नेक्स्ट वो करेगा नहीं काम. It is like that only. But these things are generally meant कि आप एक बार इसको प्रोग्राम कर दो और इसको फील्ड में छोड़ के आ जाओ. जो आपने प्रोग्राम कर दिया it will carry on doing that for the rest of the life. For जब तक कि वो ठीक है, बोर्ड ठीक है, तब तक ये यही करता रहेगा. ठीक है. So think of some examples based on simple on off thing. हाँ, अब हमने इसको ना ये वाला हम इसके बंद कर देते हैं. ये let us close this particular application जो कि हमने यहाँ पे खोली हुई है, which appears कि ऐसा लगता है कि यहाँ से मैं कंट्रोल कर रहा हूँ. Many times people tell me, मतलब जब ये एग्जांपल शो करते हैं तो लोग कहते हैं यहाँ से कंट्रोल कर रहे हो जी, वो तो क्या बड़ी बात है ना. मतलब वो कॉन्सेप्ट क्लियर नहीं होती. Now taken it out and this function also have closed in this program also have application has been closed. इसका सारा फंक्शन बंद कर दिया. Now again when I connect it, कनेक्शन करने से उसको पावर मिल गई, crystal is already there, rest of the things are already there, so it has started doing the same thing. I press it, बंद, release it, after the debounce 2-3 सेकंड का जो debounce है उसके बाद comes back. So rest of the time life it will do this only. अगर आप इसका LED वाले में ज़्यादा नजर आता है, blinking वाले में this thing becomes more clear. ठीक है, अब अपलोड कर दिया मैंने इसमें फंक्शन, वो करने लग गया. Now I close it and rest of the life it will do in this way. I've closed all the applications, removed the power. अब मैं पीसी के पावर देने की बजाय if I give a power from some other thing, किसी के पास चार्जर है, you can give the charge power from that charger. If you give a power from any other source, it will do the same thing. 5 वोल्ट वाला है, 5 वोल्ट वाला ही है ना. 4.9 के होते हैं ज़्यादातर ये. You can put it there. वो वहाँ पे इसमें लगा दो. एक रिमोट वालों को भी थोड़ा दिखा देंगे. So the remote centers, hello Gyan Jyoti and Tamil Nadu and Orissa, Hoshiarpur. What we have done is, there was a question that if I program this and remove it from the power supply, what will it do after it is taken out? So what we did is, we uploaded a simple program of blinking the LED 1 second on, 1 second off, uploaded it on the controller, removed it from the computer, and we have given it a power from some other source, basically electrical source पे लगा दिया उसको, power supply पे जो हमारी room की supply है, and it is doing the same function, right? So if you are giving, if you remove this wire also and put a battery there, it will carry on doing this. So whatever the controller is asked to do, it will do that only for rest of the life. So this is what, and the khasiyat isme and electronics, other electronics there, here you can program it as per your requirement. In case of other electronics, suppose you have made a blinking IC, a blinking function, it will blink, but you cannot change the time then. For changing the time, for making it some other function, you need a microcontroller. And a microcontroller is versatile, you can change it anytime. In this particular case, we have put a program for 1 second on, 1 second off, and it will carry on doing this for rest of the life till it is okay, right? So this is it about this particular function. Right, thank you. Okay, so with this, my demo primarily is the basic, showing you the basic function is primarily is over, but you can suggest me doing certain thing, we can do according to that, or maybe I'll ask you certain things and let us see how much have you captured the things. Any questions? Okay, then I'll ask if there are nothing from anybody. Now there was a question in the tea time. When will you use a PLC and when will you use a microcontroller? And I add to that same thing. When will you use a simple electronic logic circuit? When will you use PLC? When you will use microcontroller? And when you will use the computer? All things can do similar things. Let us say, for example, आपका simple काम है wiper वाला जो आपने बताया था. Let us say car में wiper है, right? If there is a rain, the wiper starts wiping the screen, windscreen पे wipe करने लग जाता है, right? Now what will you use for this? I will tell you that computer can be used, microcontroller can be used, simple electronics can be used, logic can be used. But what is most, what will you use? Simple, एक logic and gate लगाना है. This, rain and vehicle moving, दोनों चीजें हैं. रुकी पे vehicle चलाने का कोई मतलब नहीं है. So vehicle moving and rain, two things. And gate लगा दिया, and हो गया तो start. Simple, very very simple, right? So उसके dedicated electronics can be the best option because of cost, because of application. उसमें कोई program नहीं बनाना, right? So therefore we can use a simple electronics. एक AND gate, दो input, एक output. Output को सीधा wiring कर दो control motor के साथ. उसकी जो motor है, inputs पे दो sensors सीधे लगा दो, right? थोड़ा obviously there is more to think about it. It is not as simple as that, but in a schematic way, in a block diagram level, it is works like this. When will you use, for example, next step, let us say you have to do 2-3 things together in a car itself. Now you're using the wiper. You want to control the speed of the wiper. If there is a heavy rain, you want more wiper to rotate, wipe very fast, quickly. If there is a low rain, low. Similarly, you can sense few more things. If the car is also moving at a high speed, rain is a high speed at the, so the wiper should rotate at a highest speed. So what now is required? I'll ask whether you can use the computer, whether you can use a PLC, whether you can use a simple analog electronics, or you can use. सभी cases में yes है कि no है? All cases yes, right? All cases we can do this particular function with all the things, but we will look at the two options. One is microcontroller, one is plain electronics. What we can prefer? Microcontroller is preferable because you may have multiple decisions to make, right? And even simple electronics can be used. If you have a four-step logic, vehicle high speed, rain high speed, full speed. Rain low speed, vehicle high speed, next lower level, second level. Vehicle low speed, rain low speed, third lowest lower level. No rain, vehicle whatever speed, zero level. Right? So you have only 4 levels. Then probably you can do it in simple electronics also. You can have 4 input gate and gate. 4 inputs चाहिए कितने चाहिए? 3 levels of this, 2 levels of this, 2 levels of that. So you need a 4 input AND gate, right? 4 input AND gate में या 2 levels of AND gate, पहला gate, दूसरा gate. Gate you understand? Gate is मतलब this and this give the output yes. OR gate, AND gate, OR gate, ये gates होते हैं. So simple electronics can also be used. But if you want to make it programmable, कि आज मैं उसकी speed 4 ही level की रख रहा हूँ, but tomorrow I want to increase it into 10 different speeds. So then obviously you will use the microcontroller. ठीक है? And any such applications जो कोई आप projects बना रहे हो उसके basis पे अगर आप कुछ पूछना चाहते हो तो वो I would be happy to answer those things like how to use a microcontroller or how particular thing can be done. Yes, I'll ask individual centers. Yes, Gyan Jyoti. Any people have gone for lunch, I believe. Right, no? Already people have left. Chalo, good. Doesn't make any difference to me, no problem. Okay, next Tamil Nadu center. Kanchipuram, na? People are there. Okay, that's good. Very nice to see a lot of people still there. Any projects that you are doing and maybe interested in looking at what kind of controllers or how to use them? Or any even thoughts, can these controllers be used for these applications? Anybody not interested? Okay, no problems. Yes, Hoshiarpur, we have not heard anything from you. I just want to listen your voice. माइक नहीं है, उनका माइक नहीं है ना? So no problem. I think there is some problem with the mic, or maybe whatever. Sorry, not able to listen to you. Anyway, being you were one of the good participants, a lot of participants were there. Next we have Odisha. Odisha has been good. Odisha has left. कनेक्टेड नहीं है, क्या हो गया? ओके, चलो, anyway, that was good, nice to listen to a lot of you, and I would be happy if there are certain questions, because we have time and we can think of some. This is a very good question. I would like people to answer this. Traffic lights पे क्या आप करेंगे? Somebody from here?
It doesn't depend on the density of traffic. It's set for particular times, 30 seconds. Doesn't depend on density. It's open.
So traffic light, we have got an answer. We have got a question and an answer. How do you control the traffic light? Now I will ask you the question, how will you control the traffic light with microcontroller? Okay, slightly more, making it slightly more thinking. What you will use, digital right or analog right? Digital right only required, because you have to switch on and off only. So you'll use digital right, and suppose you want to sense the traffic density and then control. Then how will you sense the traffic density? One is with image sensor. Yes, possible. Image sensor may, if you have to use image sensor, probably you will use computer or maybe some high power microcontroller or processor. Simple things will not work. These things will not work. Let us say you are sensing the traffic density with inductive loop. There's an inductive loop. There's a simple, that's a sensor, which is basically a coil mounted in the road. Road में नीचे बिछा दी जाती है वो. बिछाने से ऊपर से उसके नॉर्मल नजर आता है, but inside the road there is a wire which senses the number of vehicles passing. So suppose you have a traffic inductive loop for sensing the traffic density, then controller में कहाँ कैसी input आएगी वहाँ पे? High analog. Question to Odisha is gone out. Tamil Nadu has gone. होशियारपुर बात नहीं कर सकते. ज्ञान ज्योति बच गया. So ज्ञान ज्योति.
Yes, sir.
We have a question. You have to sense the traffic density, and based on that, microcontroller based controlling of the traffic lights. Suppose you have an inductive loop for sensing the traffic density. What kind of inputs you will get? How will you get that?
Sir, maybe I have a brief idea that we'll set the timer for a particular light. Suppose we have 4 lights on a main point. So we'll set a timer for particular light. Based on that timer, that whole system will be working out.
Right, good. Suppose, let us say 30-second period हमने we have set, and in that 30 second, जहाँ पे red है, we sense the density, and based on that, the green value will be for the amount of density that is present.
Right. Accordingly, we can change the time if we find that there is some busy road. Then accordingly, we can make the changes of the timings of that particular road if the density is more on that particular path.
Right. That's good answer. That's exactly what I was looking. But I am asking something slightly more than this. Suppose you have a traffic density sensor. Now I am trying to ask you कि आप controller में अभी जो मैंने 2-4 चीजें बोली हैं उसमें कितना, how much you have understood in that? What kind of inputs your controller will get? मतलब, it is obviously giving one high level for every vehicle. One vehicle, it will give some kind of input. Every vehicle will give you some pulse, right? How will you get that? What will you do with that pulse?
So just a second. There's one sir, he knows the answer.
Hello.
Yeah, please.
Sir,
Sir, we have to count the number of pulses using counters.
You have to count the number of pulses. So again, the pulse inputs may be digital low and high only, but you have to then count the number of highs in a given time.
Yes, sir.
Some,
In a given time, we have to check the count value.
yeah, then you'll get the traffic density of that particular area of the road and in that given time. Based on that, you can control. So that's what I wanted to ask. Similarly, what values for controlling these lights? What kind of, for example, Abhi, with the same controller that we used,
Yes, sir.
what would be the output mode? Output for one green signal would be pin mode, port mode, or analog, digital.
Pin mode can be used, sir.
Pin
If
mode,
one light.
pin mode digital can be used. So that is what is good. Right, right. Thank you, Gyanjyoti. You are quite attentive.
Thank you, sir.
Okay, so, ठीक है ना? So this, yeah. Any question? Yeah.
We have a question, Gyanjyoti from Gyanjyoti Group of Institutions.
Yeah, please.
Good afternoon, sir.
Good
I'm
afternoon.
from Electrical Engineering Department here. And sir, my question is if I have to design a power converter for a three-phase supply, which microcontroller will be appropriate?
Three-phase power converter.
Higher supplies. If I have to design a power converter, like we may use FPGA, or else if we talk about the specific microcontroller like PIC or Arduino, which will be the most appropriate.
Yeah. Good. Can you just briefly tell me what exactly this converter is supposed to do? Is there any decision you have to make, or it is a simple converter? Means converter normally what we understand is to DC. If there is something more, you just. Yeah, please.
Sir, actually I'm designing for the power quality improvement, and our main motive is to like trigger the gate pulses whenever there is a harmonics available. So for that, my question is which microcontroller is apt for higher power supply? Like I have to work over higher loads, mainly three phase. So which one will be the most appropriate?
You see, I'll not answer your question in one step. I'll just try to ask you a few questions. Now,
Yes,
what
sir.
what is the phase angles at which you want to trigger the pulses, right? So for a 50 hertz supply, let us say, let me just give you the complete question. For the normal AC supply is 50 hertz.
Yes,
So
sir.
if it is a single phase, you will get 50 pulses per second, which means 100 half cycles per second and 100 half cycles. And what is the phase angle you want to trigger? That depends how much voltage you want to control. So from the highest peak value, which will be your RMS of the RMS value of the input or whatever voltage you are talking, from that value to the zero level, how many different levels you would like to control? First question is this.
Sir, if we set the phase angle by 60 degree,
Okay.
like by 60, by 90, by 120 maximum.
Okay.
So for that, my phase angle is I may specify 120 degree. My phase shift.
Okay. If you
For the
specify.
actually, my question is for three-phase supply. Like for ratings are increasing with the supplies. Like for the single phase, we may use PIC controller. I have designed single phase inverter. There I use PIC microcontroller. My question is, no doubt we can get. There are so many microcontrollers. Which microcontroller for the reliability purpose will be the most appropriate for the higher power supplies?
You see, there are two ways to answer your question. One is the practical, one is the theoretical, which I was giving a theory. I was giving a theoretical lecture, so I was based on theory. You can calculate the highest frequency required.
Okay.
It is not high. It is not high. Three-phase power supply at 50 hertz is nothing for a microcontroller. For giving whatever phase angle you plan, it is nothing. Even the simplest 8051 can give you suitable pulses. But the question actually, the problem actually is not with your pulses and microcontroller. The problem is with the electrical circuits do not behave in a simple way because there is a phase angle, there is a phase lag. So
Yes,
your
sir.
current, so the current actually works at a different, the current and the voltage are actually in a different phases. So if you say I give a pulse here, the things will become on and the circuit, the thyristor or whatever you're using will become on and voltage will go. May or may not happen because if there is a phase angle lag and the current has not extinguished till that point, your thyristor will not turn off, and since it will not turn off, so that there is no question of having so much of phase angle based things. Now that thyristor will not turn off. So those things are more important than your microcontroller. Even the simplest 8051 can give you sufficient pulses, sufficient frequencies, sufficient everything. But the problem actually is in the case of electrical circuit, not if your circuit is exactly 100% resistive, then
No,
probably you can do with the 8051 also.
and sir, if it will be a highly inductive circuit,
Inductive or capacitive, it is more important to look in the electricals than at the
okay, okay, okay.
microcontroller.
I got your point. As you said earlier, for the student purpose, we just for that we can use 8051, or if we are planning for a higher projects, like for the more reliable things we have to achieve. For that means in case of electrical, any microcontroller can be apt. We can use that any kind of, or is there some specific microcontrollers?
Okay, there are especially the microcontrollers come in various families and they are optimized for certain functions, right? For example, there are low power things which are optimized for low power functions. But this
Yes.
particular thing, you need a mixed signal microcontroller which will have a very good analog input things because you have to sense the voltage. So
Okay.
analog voltage sensor is required if better to have it inbuilt in the system. And there are controller families which actually you will have to look into the exact details in a certain particular case depending on the software tools that you have. If your college or school provides a certain kind of tools, if they have a IR workbench or certain things, then any processor you can controller you can use. But if there is a given set कि open source से ही लेना है या free में ही लेना है, so then there is a different constraint, right? So based on this, all that you need to do is one, your controller must have some kind of analog input. So therefore we have mixed signal controller. Mixed signal means digital as well as analog.
Okay, sir.
You can have a comparator inbuilt in the microcontroller, right? Analog, comparator, ADC, and digital. Then third thing that you can look for is PWM output.
Yes, sir.
PWM means, है ना? So
Yes.
PWM you know. So if the controller gives you a PWM output, it can give you a better way to trigger the thyristors,
ठीक है. Okay,
right?
thank you, sir.
Right.
Yes, sir.
Arduino or anything you can use, no problems. Right, so this is it. Thank you so much for your excellent interaction and nice cooperation. Thank you. Any more questions? Most welcome. Thank you.
Okay, good afternoon. So today in the afternoon session, we have a slight change in the program. There was a session of Professor B.S. Pavla on Friday. So since he's not here on Friday, so he'll be taking that session today. It is on industrial applications of automation. So Professor Pavla will be coming shortly and he will discuss with you the various industrial applications. So before that, I would like to know, take your the feedback from the centers and from the participants in the studio about the session we had in the morning. So first of all, Gyan Jyoti. Gyan Jyoti is corrected. दूसरा होशियारपुर को कर दीजिए. Okay, Punjab University Regional Center Hoshiarpur. So any feedback on the session on microcontrollers before lunch? So I think there is a problem with your either mic or maybe it is mute because we cannot hear you. We cannot hear you actually.
Hello? Hello,
Yeah,
sir.
yeah, now it is okay. Now it is okay. It's okay. Please speak. Hoshiarpur भी नहीं connect हो रहा. Bandwidth problem on our end or on their end? उनके end पे. Okay, so there seems to be some problem related to bandwidth. So we are not able to hear Punjab University Regional Center Hoshiarpur right now. Anyway, SCS VMV University. like connected नहीं है क्या? On the phone you mean? Okay. Yeah. Okay, so any feedback from the participants in the studio about the morning session? Anybody? So I think there was some demo also in the session. So what was the demo about? Okay. So did they show you how to program it and how to transfer the program? Okay, so we'll shortly begin our session on industrial applications of automation. We are waiting for Professor Pabla. He had a class tomorrow today before lunch. Another session that was on NBA. So he was late from there. So he's coming. आगे बैठ जाइए। अभी है कोई कनेक्टेड सेंटर कोई ना? शार्पर वाला भी डिस्कनेक्ट हो गया, उनकी बैंडविड्थ। और ज्ञान ज्योति में भी सेम प्रॉब्लम है। ये क्या चक्कर है सभी एक हाँ ठीक है। उड़ीसा भी नहीं है ना, बलूर भी नहीं। अच्छा सेंटर नहीं कनेक्टेड खाली हो रहे हैं वे डिस्ट्रैक्ट हो जाते हैं, वे बैंडविड्थ प्रॉब्लम है। So in other words, we have 3 participants are there and rest are our ME students. It's 16 batch वाले.
So just join.
The first day there were only 2 in the morning. 15. नहीं ME वाले कितने 10 कितने होंगे? 1 2 3 4 5 इधर CCT तो है। बैठो बैठो प्लीज बैठ के।
Rajkumar. You are joined regular?
No, sir. Contact.
बैठो बैठो बैठो।
Contacting me?
Yes, sir. Okay.
ये ग्राफिक्स एरा यूनिवर्सिटी दे रहा है।
Pushpendra Kumar.
आपके वहाँ ओके आ गया बाबू आ गया वीसी
हाँ सर, हाँ सर, वो बाबू
छोटे से छोड़ के आएगा।
हाँ सर, रिपोर्ट कैसा है?
आपके लोग क्या ज्यादा रहते हैं वीसी
ये MB स्टूडेंट पंजाब यूनिवर्सिटी वाले का नाम बोल रहे ना।
एलआर का तो नाम भी बना रखा हुआ फादर का नाम है लाला लीलू राम।
ओके ओके
पहल का पहल है ना नाम रख दो लाला
Micro.
Myself,
With
My name is Sanjay from Jawaharlal Government University. So my name is Vedant.
My name is Billy Kapoor. HP University.
JET JET ये CCD है.
मेरा नाम मामला है कॉलेज में मैंने काम किया डिग्री में काम किया डिग्री को खड़ा किया मतलब
हाँ जी सही है. दीपिका की स्टेटस है हुशियारपुर हो गया तो ज्ञान ज्योति ओके पंजाब यूनिवर्सिटी ते एक तमिलनाडु है सर एक उड़ीसा एक बनूड़ ज्ञान ज्योति 4 है कोऑर्डिनेटर डॉक्टर नीरज शर्मा है डॉक्टर नीरज शर्मा मेरा कोऑर्डिनेटर कर रहा है हाँ जी नहीं हाँ जी नहीं वीडियो आ रही सुन रही है अच्छा ओके so gate Odisha I think there was a problem in the network in the morning session I think Gandhi Academy of Technology and Education.
Yes, sir.
So now it is okay. You can hear us, see us.
Yes, sir. Yes, sir.
Okay, thank you. ये कौन सा है? तमिलनाडु. Next देखिए. करिएगा सवेरे करिएगा. 4 या 3 सेंटर नहीं है हाँ 11 ही कर लो नहीं 11 ही कर लो दोपहर तो पता शायद दूजे करने रोबोटिक्स वाले क्योंकि 4 या 3 सेंटर नहीं है गया. Okay, so we are having a problem with the net connectivity, not at our end, but at the respective ends of the centers. So right now we have only one center connected, and 2 centers are connecting, but the connection is on and off. It is very intermittent. So we, I think that we should have this session and postpone to tomorrow. So tomorrow, we will adjust it, of course, sir, we will adjust. So tomorrow morning that we will have the session at 11:30. 11:50 is tea break. Yeah. Yes. So we will have a regular session at 10 o'clock in the morning, and then we will squeeze this session tomorrow.
Okay, sir. Thank you, sir.
Hello.
Okay, sir. Thank you, sir.
Okay. बन नहीं रहा. अटेंडेंस कहाँ है आप लोगों की? भाई दोपहर की अटेंडेंस लगा दीजिए दोपहर वाली. आज लंच के बाद की अटेंडेंस लगा दो प्लीज.
ऊपर वाले स्टूडियो में एसी क्यों नहीं चलाते हो? वो तो गर्मी लग रही है. कसो एसी और लग रहा है आपको? हां एसी
So tomorrow at 10 o'clock we will start the office.
गर्मी लग रही है. मैं कल भी चले आता आज भी
पिछले लास्ट वीक बहुत ज्यादा गर्मी थी. जितना मैंने से उन्होंने लिखते हैं
चलो ठीक है दीपिका, सवेरे में 10 बजे
फोन कर।
अच्छा हो जाएगा, ठीक है।
तुम दस दो।
हाँ रेडी,
ਤੁਹਾਡੀ ਕਨੈਕਟੀਵਿਟੀ ਨਹੀਂ ਹੋ ਰਹੀ ਇਸ ਕਰਕੇ ਅਸੀਂ ਤੁਹਾਡੇ ਕਰਕੇ
मैं ठीक है जा रहे हैं।